Hello everybody, this is Ripley, and I'm going to walk you through just some introduction to statistics, vocabulary that we're going to work with throughout the whole year. Think of it as the brick and mortar of statistics. Let me preface this by saying that I cannot stand using PowerPoint at all, and I will use it sparingly and begrudgingly whenever I do. However, if I'm just introducing vocabulary, it seems to be a really good way to get through it. So, statistics, what the heck is it? We're going to give you, like I said, give you some vocabulary just so that you know what we're talking about. Some people have never had experiences with statistics before. Some of you may think that you know what it is, but just have a vague idea of how to use it. And some of you may know what it is and have no idea how to use it. So we're going to get you started now. And then we'll roll with some more information out of Chapter 1. This being our first presentation, I hope you enjoy, and we'll go ahead and get started. All right, definition of statistics. It's the collection, organization, analysis, and interpretation of data. So we take data, which we're going to define here in just a sec, and we play with it. Think of it as simply playing with data. What is this data? It's a collection of measurable observations. They have to be measurable. You have to be able to look at them as either a qualitative or a quantitative thing that can be measured. Your gender, your race, how much you make. Numbers of students would be more quantitative. You're going to give an actual number to it, and things like that. Okay? The plural for data is datum. I don't typically use that term, but you may hear it elsewhere down the line. And for those of you that don't know, this is data from the Star Trek series. All right? Okay, now, this is really the most important part. This is where it gets, we're going to start getting a little bit funky with this. First things first. The most important things that we deal with in statistics are populations and samples. Population is the entire set of things that have a certain measurable characteristic. A sample is simply a subset of the population. Now, this is introduced in sort of a strange way because we really should start with samples. Like if I want to take a sample of gifted kids, let's say think kids, well, what is that a sample of? Is it a sample of all gifted kids? Is it a sample of all gifted kids that are your age, so high school aged gifted kids? Your population is actually going to be determined by your sample rather than the other way around. Okay? So your population is everything that has a certain attribute or a characteristic, like we say gifted high school aged kids. That's a population. The sample would be think kids. It's a sample of gifted high school aged kids. Now, a census is a collection of all of the data from a population, which makes sense if you think about it in, when the federal government does a national census, in theory, although we know that they can't collect all of the data from the entire population. That means they go around to every house and they collect data from each one of those houses. Clearly there are problems. If you've got a homeless family, if you've got a family in transit, if you have expatriates, things like that, do they constitute people that are considered United States residents, citizens, et cetera, et cetera. Okay? All right. Now, these are very specific, very technical terms that we're going to use in the study statistics. One is a parameter, the other is a statistic. Notice it's a statistic, not a statistics. So the parameter is a measurement from the population, okay? So it's the average number of kids that American couples have, like in this case 2.7. Again, notice my picture. How does that happen? Okay? 9 times out of 10, we don't know what the parameter is because things are happening right now as we speak that change that. Babies are being born. Unfortunately, kids are dying, things of that nature. So a lot of statistics has to do with estimating what that parameter is. If you think of IQ, the parameter for the average IQ is 100, and the parameter for the standard deviation, both of which we'll get into down the road, is 15. Those are the parameters, and we know those because we've collected a lot of data and we've done a lot of statistical analysis of that data, and we've come up with the mean being 100 and the standard deviation being 15. Parameter means population, and then statistic, not statistics. A statistic is a measure from a sample. So the example that I give, the average number of children in my group of friends, which is a sample of all the couples in the United States, is 1.1. It's an easy way to remember it. Population, P, parameter, P. Sample, S, statistic, S. That's the way that I remember it. Okay? So when I say statistic, I don't mean statistics. Statistics is sort of this omnibus study of, remember, gathering, organizing, presenting data, things like that. Okay? All right. All right, let's talk about the types of data really quickly. Quantitative, quantity, how much? How many concerts did you go to last year is an example of a quantitative data set, if I went around to everybody and asked that. It's also, more specifically, discrete data. Discrete numbers imply they're on the natural or the whole numbers, so 0, 1, 2, 3, etc. You can't parse them up. You didn't go to 2.3 concerts. You either went to the concert or you didn't. Whether you stayed for the whole thing was entirely up to you, but that's what discrete data is. Versus continuous data, which would be how tall are you, depending on how accurate your measurement is. You could accurately measure something, out to microns if you needed to. So that's considered continuous data. All right, there can be an infinite number of measurements in that case, which can get pretty tricky if you really think about it. All right, depending on the precision of your instruments. And there's qualitative or categorical. I'll typically refer to this as qualitative, which means what type, names, labels, categories, what political party are you registered as, if any. What's your gender, what's your race, et cetera, et cetera. So qualitative versus quantitative, and then within quantitative you got discrete and continuous data. Okay. All right. Now let's talk about the levels of measurement of data. Now think of this as the ranking of the type of data that you can collect, from weakest to strongest. We can do the least amount of really interesting statistics with the lowest levels of measurement of data, and we can do the coolest stuff. Now, remember, I'm a mathematician, so I like numbers, so I have a little bit of bias in terms of these definitions, but bear with me. The first level of data is called nominal, all right? It's categorical, strictly speaking. It has no ranking. Not at all. So I know that there are arguments for certain genders or for certain races or certain foods or certain whatever as being better or worse than others, but I think we can all agree that our data sets, they're categorical data sets where there's no inherent rank to it at all. Okay? So that's nominal, like I said, gender, race, favorite food, type of car, et cetera, et cetera. Okay? That's nominal. There's ordinal, and this is kind of ironic if you notice. Ordinal data, it's still categorical, except it has an implied order. So things like low, medium, high, compact, mid-size, SUV, that has a ranking in terms of size. And then, strangely enough, our system of grading is also simply ordinal. It's categorical in theory with that order. All right. In other words, the biggest part that you have to understand about ordinal data is that within those differences, within those ranks, differences don't make any sense. If I get an A on my test and you get an A on your test without any more information, we don't know who did better. I know that A is better than B. I know that B minus is better than C plus, but I don't know how much better. Does that make sense? You can answer that tomorrow in class. Okay? So that's ordinal. So we got nominal, we got ordinal, and we have interval. All right? Interval is when we start really launching into numerical data. All right? Numerical data, now in this case, think of it as the differences within groups are meaningful. But the problem with interval data, why it's not the strongest, there are only 4, by the way, we'll go into the 4th one here in just a sec, is that there's no absolute zero. So think of temperature as being interval. There's no, I understand that we could make the argument that there is an absolute zero, the temperature at which molecules stop behaving the way molecules behave, but there isn't an absolute zero. Things like temperatures, dates, or IQ are considered interval notation, or interval data. All right. Now, another way to determine an interval level of data is that ratios aren't preserved. Now, let me explain what this means. You can tell in my little PowerPoint here. If the temperature is 100 degrees Fahrenheit, it's not that it's twice as hot as when it's 50 degrees Fahrenheit. So, because we don't really have a way to say, okay, well, that's that. I'm twice as hot. Temperatures don't behave that way, okay? It's not like it's a linear type deal. Also, think of IQ. A person with 120 IQ is not twice as smart as a person with a 60 IQ, all right? Now let's talk about a little bit about dates. Dates, I guess we could make the argument time-wise that if I was born in 1970, I'm twice as old as somebody who was born in, now we're going to get tricky, in 1991. That would be half the distance. That's true, but dates don't have that absolute zero, and now we're not talking about time, we're not talking about measuring time, we're talking about dates across the spectrum. But we can still gather data in terms of, when somebody was born or when something started, et cetera, okay? And then last but not least is a ratio. Now let's talk about the ratio level of data. All right, it's the same as interval, but it's got a zero starting point. Like the amount of gas I have in my car, I could have no gas in my car. The amount of time it takes to complete a task, all right, it could take no time to complete a task. Height, there theoretically could be a zero height. Weight, there could be something that weighs nothing, okay? Ratios are preserved. 160-pound man weighs twice as much as an 80-pound person, okay? Think about it that way. Again, if I have 10 gallons in my car, I have twice as much gas as if I have 5 gallons in my car, okay? So that's all right, so that's it for this presentation. My recommendation would be, if you're having trouble remembering the vocabulary, just old school, write up some flashcards to help you remember them. I'm going to be throwing these types of vocab words out over the course of the entire semester, so you're definitely going to want to have a command of them. I think there are some like flashcard apps that you can get for your phones too, just to kind of cruise through those. They don't work great for some of the mathematical stuff, but for the vocab stuff they work great. Okay, go ahead and look on the website for the other videos that I want you to watch out of Chapter 1 and Chapter 2, and then we'll see you tomorrow, and have a really good day. Bye-bye.